All right, in this short video, we're going to look at the sum of the exterior angles of a polygon. You should have already watched the video over some of the interior angles because we're going to draw on some of that knowledge to do what we're doing in this video. So first off, let's define what an exterior angle is. And an exterior angle is, now this says of a regular polygon, but it can be true for any polygon. It's created by extending one side of the angle, or excuse me, one side of the figure. So this is what we call an interior angle. And then this out here that I'm showing in green, this would be an exterior angle. So there's a couple things we need to know about that. For one, we know that the relationship between an interior angle and an exterior angle is that they're supplementary, okay? But what we're also need to know is that it doesn't matter if I extend it that way or if I extend it that way. And here's why I say that. If I extend it that way, here's our exterior angle, right? But if I extend it this way, here's our exterior angle. And these are going to be vertical angles. So it doesn't really matter which direction you extend it. It's going to be the angle is going to have the same measure regardless. So what we're doing in this video is we're finding the rule for the sum of all the exterior angles. So for this pentagon, what if I drew all 5 of those and added them all up? What would be? What if we did a hexagon? What if we did a heptagon or an octagon? But that is what we're looking at. And to do that, I'm actually going to pull in this GeoGebra applet. I'm going to link this in the show description because it's perfect. This is created by Alex Fetterman and Tim Brzezinski. Guys, thank y'all for making this. This is just a beautiful representation of the idea. And so here's what we got. So I've got this triangle here. We know its interior angles add up to 180, but what do its exterior angles add up to? And so one exterior angle is shown right there in red, okay? Now I'm going to come over here, and then we got our second exterior angle that's shown in blue, and then we've got our third exterior angle that's shown in green. And it looks like in this case, these 3 angles have a sum of 360. They go all the way around, right? And so if I were to back up, I like this applet because it shows that it's not just a coincidence. I can move the triangle around and we see, okay, there's my first angle, okay? There's my second angle in blue, and there's my third angle in green. Once again, still adds up to 360. So the exterior angles of a triangle, it appears like they add up to 360. Let's look at a quadrilateral. Okay, let's figure out what the rule is for a 4-sided figure. So I've got a random quadrilateral here. It's not regular, okay, because all the sides and angles are different. There's 1 exterior angle, 2 exterior angles, 3 exterior angles, and oh, okay, interesting. It looked like even though a quadrilateral has more sides and therefore more exterior angles, right here the exterior angles still added up to 360. It still made that full circle. Oh, okay, well, just to be sure, let me kind of move some points here and make sure that wasn't a coincidence. You know, I can do that, and I can widen out one of these angles and do that. Now let's see if it still adds up to 360. So there's my first exterior angle. There's the second one. There's the third one. And lo and behold, so it looks like both a triangle and a quadrilateral's exterior angles have a sum of 360. Okay, just to be sure, let's look at a pentagon. And I'll be brief with this one because you might already see where this is going. There's our first angle, second, third, fourth, and this one has a 5th exterior angle right there. And there it is. So what we see is that no matter what shape we have, no matter how many sides we have, the sum of the exterior angles is going to be 360. The sum of the interior angles, we had to use that formula, 180 n minus 2. But for the sum of exterior angles, it's a constant. It is always 360. I think that app, that GeoGebra program that they wrote, does a great job of visualizing that. So now that we have kind of our new knowledge, let's use it to answer a few questions, okay? So we're going to answer these 3 questions, and then after that, I'm actually going to show you a little bonus content which kind of connects interior angles and exterior angles. So make sure you stick around for that. I think it's super interesting. So first off, what is the sum of the exterior angles of a 500gon? 500gon, a 500-sided figure, you might see that and panic, but oh yeah, remember, it's always going to add up to 360. It doesn't matter how many sides. So that's actually the easiest question ever. Now, it says one interior angle of a regular polygon has a measure of 157.5. How many sides does the polygon have? There's more than one way to answer this question, but I want us to use our knowledge of exterior angles to answer it. So one thing that we need to know is that the exterior angle and the interior angle are supplementary, meaning if I did 180 minus my interior angle, it would give me the measure of an exterior angle, right? And if this is a regular polygon, all of those exterior angles are going to be equal, right? Well, if I know that there's 22.5 degrees in one of the exterior angles and I divide by 360, that's how many of those exterior angles does it take to make your total of 360. And in this particular case, it's 16. So our figure is a 16gon in this case. Now, lastly, is it possible to have a regular polygon with an exterior angle of 40? What about 50? Well, what we know is that if I have 360 total degrees worth of exterior angles and we divide that by 40, you would get 9. That would mean, yes, it's possible. In fact, that's a regular nonagon. It would have exterior angles of 40 degrees each. Now, if we did 360 divided by 50, you would get 7.2. And in this particular situation, it doesn't make sense to have 7.2 exterior angles or 7.2 sides. Therefore, it's a regular polygon. No, it is not possible to have an exterior angle of 50 degrees. But yes, it is possible to have an exterior angle of 40 degrees. Now, here's the last thing I want to look at. Because you might be sitting here and you might be saying, okay, Mr. Horn, I get it. We talked about interior angles. We did that. It seems weird to me that the exterior angles always add up to 360. I feel like it should get like bigger or smaller depending on the number of sides. Well, this is an algebraic way of showing that relationship that I think is kind of nifty. Now, I've got a figure right here. I've kind of cut off side of it, so we don't know how many sides it has because we're trying to generalize, right? And what I'm going to do is I'm going to try to help us understand, help us see another way why the sum of those exterior angles is 360. So if I look at it this way, we know that an interior angle plus an exterior angle together are supplementary, right? So I could say that this is 180 degrees. And I could say this is 180 degrees. And I could say that this is 180 degrees all the way around. So if I add the interior angle and the exterior angle together, that is 180 degrees. And the question is, how many of those little supplementary angle pairs exist? Well, there would be n of them if we had an n-sided figure, right? But think about what this number represents. This represents the sum of all the exterior angles and the sum of all the interior angles, right? So if I wanted to represent just the sum of the exterior angles, we could then subtract the sum of the interior angles. So if all these interior angles are represented by 180 n minus 2, as we learned in our previous videos, if I take all those interior and exterior angles together and subtract out the interior angles, this should simplify to be just the sum of the exterior angles. So let's look at it algebraically. If I distribute my negative 180, we have negative 180n, and then negative 180 times negative 2 is plus 360. And then I bring down my 180n. Well, 180n minus 180n, that adds to 0, and therefore we are left with 360 degrees. So I just wanted to tack that onto the end of the video because I think that's a really interesting representation that can kind of show the relationship between those two relationships, the sum of the interior angles and the sum of the exterior angles. So hope this video was helpful.